Hello. This lecture will cover pages 265 through 266 of my lecture notes. Please print those pages out and have them in front of you as I present this lecture on digital arithmetic 6D, BCD Arithmetic. Starting on page 265, I want to discuss how you handle BCD numbers when you add them. I'm only concerned about BCD addition. If you remember binary coded decimal, it was a compromise between the human being and the computer systems in that we want to use decimal, the systems want to use binary. So the compromise was within each nibble we were binary, but from nibble to nibble we represented decimal digits. And if you remember, the codes 0000 through 1001 were the only valid BCD codes. If you will, the Alpha, Baker, Charlie, Echo, Delta, Fox were all illegal. They were not allowed. Because if you added up numbers, or if you wanted to represent the number 10, Alpha, you'd have to break it into a 1 and a 0, which would require two different nibbles. Looking at the BCD arithmetic, if you add two BCD numbers and you get an illegal code, one of these illegal codes, you need to add a binary 6 to correct for that sum. It's a correction factor. And the reason you're adding 6 is because you have to skip over the 6 codes. You have to allow to skip over these 6 invalid or illegal codes. Now, what I've done is I've put together 3 examples for you here on page 266. And you're going to see this probably on a quiz or an exam, but you're also going to see it in future courses in your microprocessor or your classes. In your microprocessor classes, you're going to see this, where you're going to have to write algorithms to handle BCD arithmetic. So my first example is I'm going to take a 6, a binary straight, unsigned binary number 6, and I'm going to add it to 6. And I should get a 12. Well, if you add those up, you get a 0, you get a 0, you carry a 1, you get a 1, you carry a 1, and you get a 1. You get a Charlie. That's an illegal sum. So you have to add 6 as a correction factor. And when you add the 6 and you break this up into 2 nibbles, there's your 1, 2. There's your 12. 6 and 6 gives you 12. We needed a correction addition here. Look at example 2. I have a 59 and a 38. When I add a 59 and a 38, it's a 97. Well, here's my 59 represented as straight binary. Here's my 38 represented as straight binary. And very carefully you add these up. And I want you to notice that in this first nibble, you're going to get a half carry. We call that a half carry. That 1 and a 1 gives you a 0, and it brings up the half carry. And when you continue to add these up, that half carry also initiates a corrective action. Notice this 9 and this 1 are illegal codes, but because we get this half carry here, you have to add the 6. When you add a 6 to this, I'll let you add those up. I want you to notice you get your 97. So what we found out here in this second example is you need to add the corrective 6 both if you get an illegal code or if you get a half carry. Let's look at example 3. A 47 and a 35 should give you an 82. Well, here's my 47 in straight binary. Here's my 35 in straight binary. And I'm just going to add those up very carefully. I want you to notice that we get an illegal code here of Charlie again. We have to add 6 to that. Once we add 6, we end up with a half carry down here, but we already made a correction. You don't add a correction again. So you take this half carry and just add it in the way you would normally. And notice that the codes are both legal. There's your 8. There's your 2. You get an 82. Well, keep in mind, if we have an illegal code, if we'd have an illegal code over here, we'd have to add 6 to this point. So here's 3 different examples of how to handle BCD arithmetic. And in summary, we talked about only binary coded decimal addition. is all I want to concern you with here in this part of the course. And we said that if you ever ended up with an illegal code in your addition, as we did here, you have to correct for it by adding 6. Or if you get a half carry on your initial adds, you also have to add in that corrective 6. What I'd like you to do is just pick a couple of these numbers on your own. Pick some decimal addition here and see if you can do it using BCD Arithmetic. And that concludes this lecture on BCD Arithmetic.